Hi, my name is Nate Bastian, and this is Design for Development. I started this project researching Niger in West Africa, and one of the things that I found most interesting, one of the most shocking statistics right off the bat was the infant and child mortality rates. And you can see on this map, Niger's infant mortality rate is among the highest in all of the world, just sharing that with just a few other countries. And the child mortality rate is for children under the age of 5, and that's very high as well at 25%. So that basically translates to 1 in every 4 children won't live past their 5th birthday. So after I found those statistics, I looked at the reasons why the child mortality rate was so high. And I found that two of the leading causes are pneumonia and malnutrition. So I focused my project looking more specifically at pneumonia and trying to figure out why is it so deadly in developing countries, and especially in Niger. And what I found is that I researched pneumonia a little bit more and found that pneumonia becomes fatal in severe cases when you get a deficiency of oxygen in your bloodstream, and that's called hypoxemia. And the only way to treat severe pneumonia when people have hypoxemia is to administer medical oxygen. And that's practiced, all over the world. And medical oxygen is used for all different types of complications that will cause hypoxemia. So in Niger, I've discovered that there was a relatively limited access to medical oxygen. In the larger capital city of Niamey, in their hospital, they have access to large generators that supply the whole facility, but it's a multi-million-dollar setup. So in more rural hospitals, the access is very limited. And the World Health Organization study found that they phrased it in the way that oxygen is not always available in 80% of district hospitals. So sometimes it is, sometimes it is not. So I started to look at medical oxygen and get an overview of how it's generated and how it's used and where it's used. And just kind of like I touched on a little bit before, you kind of have three different ways that medical oxygen is generated. The first is an industrial oxygen generator, and that, like I said earlier, is a large multi-million-dollar setup that would be installed at a hospital or a facility, and it would supply the entire hospital with medical oxygen. That's the typical model that you would find at a hospital in the States. The more common model for rural areas would be oxygen tanks. So that process is basically the tanks are filled at a place like the district hospital, like the hospital in the capital city, and then they are trucked out to the rural areas. It's the use of the oxygen tank system that causes there to be a really inconsistency with the access to the oxygen in the rural hospitals, especially with poor road conditions and the fact that the tanks then have to be removed, and it's just not a very sustainable process. So the third way to generate oxygen is an oxygen concentrator. And this is a small, about 2-foot high, portable oxygen generator. And these were designed to administer oxygen in home use and travel use. So generally elderly patients they're marketed to who have breathing complications. And these devices were designed for the States, and they're pretty expensive, anywhere from $800 to $1,200 for one of these devices. What makes the oxygen concentrator so interesting is that as I was researching them, I found that the World Health Organization did a large study in Malawi in 2007. And what they did was they tested the implementation of using oxygen concentrators in district pediatric wards at district hospitals. And the study showed that it's very feasible and it worked very well, but they're still relatively expensive, and not all hospitals can afford them. So there are programs that are trying to fund the distribution of concentrators in rural hospitals. So at that point, I started my design process, and my mission is to develop a product and a system that can supply affordable medical oxygen to rural hospitals. It was really crucial that the oxygen is generated on site because it's more sustainable and it's longer lasting. And the key phrase for me in this process is affordability, because it's proven that the concentrator system is effective. And I want to make a system and a product that can lower that cost by 50 to 75%. So this was kind of 7 or 8 different ideas that all focused on ways to lower the cost and get oxygen into rural hospitals in Niger. And I just want to point out some of the areas that I liked the most and wanted to continue working in. Was number 2 here. I found that because these oxygen concentrators are used in the States for home use, a lot of the time the patient recovers. So then there's an oxygen concentrator that has no use. And a lot of times they don't have a very long life. So there's companies that specialize in refurbishing and reselling used oxygen concentrators in the States. So that's where that idea came from. And another thing that I found really interesting is how if you take the assembly and manufacturing out of the equation and leave that up to the end user, then you're saving a lot of cost. And I really like that idea. And some of the ideas I didn't like was to simplify the technology. I thought about ways to kind of reduce this device to maybe just something handheld that you could breathe through. But my research proved that that's just not realistic. And the way oxygen is generated in these concentrators is basically through a system of a microporous filter that filters out the nitrogen, and it uses a compressor to have that process work effectively. So from there, I came up with this idea, and this is my system overview. So the system would start in Bethany, Missouri, and this is a company called Accurate Biomed, and they specialize in refurbishing oxygen concentrators. So one of the things is if a concentrator comes to them and certain pieces are broken or damaged, then they don't have all the pieces to reassemble a full concentrator. So there are fully functioning components of concentrators that don't have a home. So I'm interested in taking all the components of the same concentrator so they're all compatible, and that brings to the next step, which is adding off-the-shelf components. So nuts, bolts, hardwares, mounting brackets, wheels, casters, whatever you need to take the components and add to it to make a fully functioning oxygen concentrator that has the same functionality but at a lower cost. So at this point, Medicine Sans Frontières, which is Doctors Without Borders, I looked a lot at them because they have a lot of action in Niger and all over the world. And they have an office in New York City. So the next step of the system is that volunteers at Doctors Without Borders in New York City would take the components off the shelf and the components bought from Accurate Biomed and would assemble them, not assemble them, would just pack them into a shipping crate that could be sent to Niger. The shipping, it was really important that the shipping was concise and as nested as much as possible to minimize any type of cost on that end. And they would arrive in Zinder, Niger, where at the MSF location there, and from there they can be distributed into Niger. It's important that Doctors Without Borders was involved in the distribution because there's going to be a dialogue. It just happens to be a coincidence that they speak French and Niger is a French-speaking country. But there has to be a dialogue between the hospitals that are buying these from Doctors Without Borders, as far as just setups, training. And one of the key features is that instead of installation instructions, assembly instructions would be packaged in the crate, so you can assemble the product. And the assembly process can also serve as a training exercise to get to know all the different components and their functionality.